So I'm making this video on a certain question of the practice test that I forgot to make a video for. This question number 25, it says select all divergent geometric series. Okay, so first of all, you need to know your vocab before you actually start deciding which one's a divergent geometric series. What is a series? It's simply a summation. You keep adding numbers and adding and adding numbers. And if it's divergent, that means what? What does it mean? That the R is greater than 1, which means that you're going to be adding a bigger number and a bigger number and a bigger number, and it's going to grow forever. So divergent technically means that it's going to infinity. All right? Divergent means that it goes to infinity. Okay? Convergent, that's when you actually have a numeric answer. That's when your absolute value of R is less than 1. That way, when you're adding with your next number is smaller, and then your next number is smaller and smaller and smaller, and ultimately you're adding a number that's so small that it doesn't make a difference, so it will converge to a certain value. So divergent means that the common ratio is bigger than 1, which is going to cause it to go to infinity. Convergent, your common ratio is less than 1, which is going to converge to a certain value. Now, when it's convergent, when your R is less than 1, then you are able to use that infinite summation formula, which is a fraction with a sub 1 over 1 minus R. And that'll give you the specific answer to your infinite convergent geometric series. But the only thing they're asking here on this question is select all divergent geometric series. So, do you think this will converge or diverge? Is this, it converges, right? Why? Because it's a number, and then you add half of it, then you add half of that, and then you're going to keep adding half, and at some point you're going to add something so small that it's not going to be getting any bigger. And on this problem, you would be able to use this formula because the common ratio is 1/2. If you're thinking, well, what is he talking about? The common ratio is 1/2. If you go 24 divided by 48, that'll be 1/2. If you go 48 divided by 96, that'll be 1/2. So on this first one, the common ratio is 1/2, which makes it convergent. And right here, what do they want? They want divergent. So this is not it. If I remove this box, you'll see a red mark. Do not pick this one. This is convergent, not divergent. Okay? Now, it's one thing to see the list of numbers. It's another to look at the summation, the sigma notation, which is a summation. And you got to recognize that this right here is in the form of a geometric a sub nth rule series or sequence, right? The a sub nth rule of a geometric sequence is a sub 1 times a common ratio r to the n minus 1 power. So that's what we have here, a sub 1 times common ratio r to the n minus 1 power, but instead of n we have k because we have k from 1 to infinity. So the question is this one a divergent geometric series? What do you guys say? It all depends on your R value. What's your R value? It's greater than 1, isn't it? 3/2 is 1.5. So this guy will be divergent. So right here, you're going to select this one. We're going to see a green mark. There it is. This is definitely divergent. This one's convergent. This one's divergent. How about this guy over here? Is this convergent or divergent? Or actually, forget convergent or divergent. Let's just answer the question. Is this divergent? No, it's not, because the R is less than 1. That's convergent. So don't pick that one. How about this guy? Is it convergent or divergent? It's divergent. Now, let's be more specific. Is it a divergent geometric series? In order for it to be, I mean, there is such a thing as a divergent arithmetic series. Is this a divergent geometric series? Does it have a common ratio? What's 64 divided by 32? 2. What's 32 divided by 20? Is it 2? No, it's not. So is it getting bigger and bigger and bigger? Will it go to infinity? Is it divergent? Yes. But is it a divergent geometric series? No, right? I even messed up on typing it in. I put a comma right here. I should have put a plus sign right there. But either way, it's not a divergent geometric, because for it to be geometric, you need a common ratio. 64 divided by 32 is 2. And 32 divided by 20 is not 2. So there is no common ratio. So it cannot be geometric. That's why we did not pick that one. Yes, it diverges. 20 plus something bigger plus dot, dot, dot. Yeah, it's going to diverge to infinity, but it's not geometric. How about this last one? Is this a divergent geometric series? A lot of us are going to say yes because the r is greater than 3. But let's really think about what the definition of a divergent geometric series is. It has to go to infinity, right? And this is an actual summation problem that starts at 1 and ends at 5. We're talking about 5 numbers only. Will this go to infinity? No, it doesn't. It has to go from 1 to infinity in order for this to be a divergent geometric series. Does that make sense? Yes, the common ratio is greater than 1. That means it's going to be growing from one number to the next, but it's not going to infinity, so the answer cannot go to infinity. This answer is a specific answer. You would have to use a summation formula to actually figure that out. But it's only 5 numbers long, so it cannot be a divergent geometric series because it doesn't diverge to infinity. It actually is a specific numeric answer. Any questions?